Hello everyone, welcome back. So in this video we are going to understand the problem number 1461 from the Leetcode. So let's imagine I'll give you a binary string and I ask, does this string contain every possible binary code of size k or not, right? So it look like a sound very simple, but the most people will overcomplicate this problem. And because why? Because the trick is just a mathematical observation. So let's try to understand here. Okay, very first we have given a binary string s, as you can see here, right? And we have given integer k. So we must check, does this s contains all possible binary combination of size k or not, right? So if the s contains all possible binary combination of size k, so how we'll check? Let's suppose that we have given this string, right, and k is 2, we have given. Now pause for a second and think that if the k is equal to 2, how many binary combinations exist here? So let me write here. So if k is equal to 2 means we should check how many binary combinations exist here. So combinations are, let's suppose 0 0 will be there, right? 0 1 will be there, 1 0 will be there, and 1 1 will be there. When if k is equal to 2, if k is equal to 2 means these are the combinations, right? What we call we can say this is nothing but a binary combination which is possible, right? So if k is equal to 2, these are the binary combinations. 0 0 1 0 1 0 1 1 is there. So these are nothing but, we can say, is 2 to the power k, and if k is equal to 2 here, it means 2 to the power k, so it is nothing but 4 as a combination. There will be 4 combination. I hope you understand this. So the real question becomes here, does our given string s contains these 4 substring or not? If these 4 substring are existing, so we will return true or false. Okay, this is what the question says that. So let's check how we are going to check. Let's think that we have given this string. In this string, if you see, we have let's take with the steps. So we'll take in step 1 where we'll say, okay, that we have combination that we have here is 0 0 1 1 0 1 1 0, right? This is what we have given as a s equal to, right? So from here we'll say, okay, the very first step we took is we have 0 0. This is the combinations we have. From here we can say 0 0. Can we say that this is what we have given? In step 2 we will say, okay, now this time we'll move ahead and we'll find the combination, right? So next we'll start from here. We'll get 0 1, so we'll get here 0 and 1. It means the combination we have is 0 and 1. It is existing. Similarly, for step 3, for combination 3, we can say is we have, when we reach from here, we'll start from here, right? Means we will get 1 1 1 1. So this is also existing, 1 1, right? These are the combinations we are looking for, right? Let's check further. Now when we reach to here, we will get 1 0, right? In step 4 we'll say 1 0. When you reach here, this is 1 and 0. It means we found all these 4 combinations that we were looking for. If k is equal to 2, it means these 4 combinations we required, and that is already found now. So no need to go further. Okay, we already found what? We already found 0 0 1 0 1 1 and 1 0, right? So we should return answer as a true. Correct, guys? This is what we are looking for. Now you will say, what is the core idea and so to solve this problem, right? Basically, for any k that we have given, right, for any k, total possible binary code will be nothing but 2 to the power k. It means total possible binary codes will be 2 to the power k, like this. If k equal to 2, we will get 0 0 1 0 1 1 and 1 0. So like this, there will be some combinations will be there, and those combinations should be existing in the given string. So instead of generating them, just we do a sliding window, right? We are taking a window of size 2, right? We are checking this one, then our window become this one, then our window becoming these two, like that. Our window will be fixed, right? So just slide the window, store unique substring, like we are saying that, right? If we are storing all the substring like 0 0 0 1 1 0, like this, right? If the unique counts is 2 to the power k, if unique count is 2 to the power k, right, means we will return true as an answer. That's it. The problem is a counting. Okay, this problem is counting. Let's do some, because the problem is counting, right? It's mathematically, so we should understand some important check. What mathematically check we have to do? So we should understand. Let's suppose that before coding, right, ask yourself, maximum substring of size k, right, we have to find. Okay, it means what will be the maximum substring of size k? The s we have given, let's suppose s dot length. If we'll do s dot length, right, from here, if we find the maximum substring, what I'm trying to say, if you want to find the maximum substring of size k, okay guys, how we will find that? We'll say s dot length minus k plus 1. If the s dot length, let's suppose, is, if we'll say s dot length minus k plus 1, if this is less than 2 to the power k, so this is impossible. This is impossible, right? You can check on these inputs. If you will put this value, you will understand. So you don't even need to compute. Okay, just let's suppose for this case 0 1 2 3 4 5 6 7, right? 7 minus 2 is 5 plus 1 is 6, right? If it is less than equal to 2 to the power k, yes, it is less than, it means it's true. This is fine. If you'll put like this, means this is already 4 minus k is already 2, is 2 plus 1. Is this less than 2 to the power k, right? No, it's wrong, so we will return false, right? It means if this condition is there, so it is an impossible case, right? You don't need to even count these things, you just check with this one, and that's level is called interview level thinking. Okay, so you should think like that. Let's come back to the code so you will understand. So if you come here, the given constant we have s dot length is less than 5 to the power 5 into 10 to the power 5, and s at I is either 0 1 because this binary string, and k is greater than or equal to 1 and less than 20. Okay, so if you'll come here, give me 1 second. Yeah, so okay, so very first, that what we need is 2 to the power k, and for that you have to take one left shift k, that is our needed, right? So we'll take a HashSet to store the substring, right? And very first we will use the sliding window, let's suppose, and for that you will get the size of the substring. So this is, we are going to start at I and we will go to I plus k. so it will give the substring of size that window. Okay, so all time we are generating the substring. Basically we'll start from 0 itself and we'll keep moving ahead. Let's suppose we had some value 0 0 1 0 0 1 1, like that we have, right? It means I start from 0 1 2 3 4 5 6, like that. Okay, so each time we need a window of 2 only, right? It means if I is at here, this is our I. If I is at here, we'll get this window. When I is to the next window, right, means we need these two window, like that. So we'll need the substring. This is called substring window, right? From here to here, here to here, like that. We will find the substring and we'll add over the scene as a hash set, right? So because the set contains only what you call the unique values, right? It will not allow the duplicate value. We don't need the duplicate value. Like that we have to go. Now we'll check if the size is equal to the need, right? Means we, let's suppose for this case, right, 2 to the power k, if k is equal to 2, it means we need maximum 4. It means if the set has size is 4, means the condition matches. So it means all the possible combination like 0 0 1 0 0 1 and 1 1, these 4 conditions are already matching. These substrings are already in the hash set, so we don't need to do anything. We'll return true. And if the size is equal to needed, then we'll return true or false. Means it is equal, means true. It's not equal, it will return the false. So the thing is, it's very simple. You should understand what the approach is. This is mathematical problem, right? Let's talk about the time complexity, guys. Okay, so that if we talk about the time complexity, right, if there are the possible combinations become for the substring, right, means we'll go for n into k will be the size. Okay, so this will become O of n, we can say, into k. Similarly for the space combinations, the total combination become 2 to the power k, because we are going to store 2 to the power k only, right? So this is nothing but 2 to the power k combinations as a answer. Okay, for the space complexity and time complexity. That's a good enough for the most cases, guys. And if you want to optimize this thing, you can do the optimize thing through the Bitmask solutions, but substring creation cost will be there. We can do better instead of storing this string there. Okay, so you can try the bit manipulations or optimize Bitmask solution. Okay, we just need to, we will not use this because this substring creation is taking time, right? And after that we are also storing into the set. So we can convert this window into a number. Let's suppose if we have 0 0, we will convert into 0. If we have 0 1, we will convert into 1. If we have 1 0, like 2, 1 1, then 3, like that we can convert this, right? We will convert each window into a number, and now we will use a bit shifting, right? Let's suppose how. So if you see here, right, we have commented this previous code, right? It's working fine, you can try with that. But now we have is needed will take as a shift of this, that is needed. We can take only boolean array, right? We'll check as from 0, we'll take mask needed -1 count. And what we need to do when we are going here, right, we will just check has masking, and then we can come further and we'll check if it is available, this has is available, right? We just need to count plus plus, and if it is equal the need, we will return true, otherwise we'll return false, right? So try this one, because it takes O of n as a size. It is very optimized code, and that's all I have in this video, guys. So what is the takeaway from this video? That you understand the sliding window knowledge as well as the combination of 2k. This is a bit manipulation code. We have seen the how you will optimize, how do the early exit optimization, how we'll understand mathematical thinking, and that's what we have in this video. So if you like this video, you can comment into our comment box, and if you have any doubt, you can ping me in the comment box. I'll definitely help you there. In case of you are seeking with the DSA preparation, you can join my online classes, and for that you can inquire in our WhatsApp channel. Thank you.